My name is Hongyi Zhang, and I'm a senior student studying computer science here. My final project is image quoting. The main problem of this project is to sample patches from the input image and then put them together as a bigger image while keeping the original texture of the input image. To do this, we implement the method in 3 steps. The first method is random sampling. For this one, we sample randomly a patch from the original input sample with the specified patch size, and then put them together as a larger image. And the result for this method is really bad. You can see that it has very noticeable seams, and the texture doesn't seem right at all. The windows aren't aligned, and it just doesn't look right. The second one is overlapping. For this one, the patches will no longer be just placed next to each other. However, they will have an overlap region. And for each new patch that we put into the output image, it will have to have a minimum SSD, which is sum of squared difference with the template, which is the place in the output image that the patch is going to fill. The hard part of this algorithm is that I need to calculate the SSD of all patches with respect to this template at all locations of the output image. You can see that it's very good, a lot better than the previous one. The third one is image quoting. For this method, the first section of code is the exact same as the previous overlapping method. After getting the patch with the lowest cost, we will need to calculate the path along which to cut the seams. Using the provided cut method, I got the path and made a mask to combine the current output image with the new patch. Here's the result of the same example. And this time, it's even better. So here's a side-by-side comparison of the 3 results from the 3 methods. But now, you might think the latter 2 are similar. Let's take a closer look. So this is a zoomed-in version of the second one. Once it's zoomed in, you can see that it has a lot of artifacts. Here, for example, you can see that the window is not aligned. And here, for every window in the original picture, the bottom part of the window is going to be the same color, either blue or black, but now it's divided in half. And also you can see the borders of each patch very clearly here, like along this line and along this line. And here it even has a black horizontal line separating the image. For the third one, there are no such problems. Some other examples I have, so the first 2 are from the paper that originally brought up this method. You can see that the brick wall and the wall texture are both very good. This one on the left I took myself, and there are some parts that don't really look good here. Fourth one, it's a strawberry pile, and there are also some parts that has some artifacts. For example, here, you can see the strawberries merging into each other. For this project, I had to learn a lot of MATLAB functions and fully understand the image quoting algorithm. I enjoyed putting input images and seeing them become a bigger texture image with my code. It was really satisfying. The strength of the method is that it's very effective on repeated textures, like the building image and the brick wall image that I demonstrated. However, it's not very effective for a non-repetitive texture, like the strawberry pile image I showed. Potential for improving my implementation specifically is to use the filter for generating SSD instead of calculating them directly for every patch. And that's all of my presentation. Thank you.